In this video, I'm going to solve the problems in mini test 2.1, 2.2, and 2.3. Question number 1, part A says simplify x squared plus 10x plus 21 over 2x plus 6 and specify the restrictions. Since the numerator, the leading coefficient, meaning the coefficient of x squared is 1, I can use sum and product method. I can try to find two numbers. The product is 21 and the sum is 10. Those two numbers are 3 and 1, so the numerator can be written as x plus 3 and x plus 7, and the denominator, since 2 is common between them, I can take the 2 out, so I get x plus 3. Before I simplify and cross out x plus 3, I'm going to make the denominator equal to 0, so x plus 3 equal to 0. I get x is negative 3. So this means the restriction is that x cannot be equal to negative 3. Now safely I can cross out x plus 3, so the answer becomes x plus 7 over 2, and x cannot be equal to negative 3. The second question, we have to simplify 2x squared minus 2x minus 6 over 3x squared minus 24x plus 36 and state the restriction. The numerator, since the leading coefficient is 2, I cannot use sum and product method. I have to use a technique, something like decomposition method. In the numerator, the coefficient a is equal to 2, b is equal to negative 1, and c is equal to negative 6. So ac becomes 2 times negative 6 is negative 12, and b is negative 1. Two numbers that the product is negative 12 add up to negative 1 are negative 4 and 3. So the middle term can be decomposed in negative 4x plus 3x, so I can write the numerator as 2x squared, negative 4x plus 3x, which is add up to negative x minus 6. Now I can group the first two terms and the last two terms together. From the first two terms I can take 2x out, so I get x minus 2. And from the last two terms, I'm going to get the 3 out. So I get x minus 2. Now x minus 2 is common between them, so I factor out x minus 2, and I get 2x plus 3. So here, the numerator can be written as x minus 2 times 2x plus 3. Over, now the denominator, I can see that 3 is common between all three terms, so if I factor 3 out, I get 3x squared minus 8x plus 12. Now the leading coefficient, meaning the coefficient of x squared, is 1, so I can use sum and product method. I'm going to try to find two numbers. The product is 12 and add up to negative 8. Those two numbers are negative 6 and negative 2. So I get 3 x minus 6 x minus 2. So the denominator becomes 3 x minus 6 x minus 2. Now, before I simplify any term, I'm going to write restrictions. You can see that the denominator can only be 0 when x is 6 and x is 2, so I can say that x cannot be equal to 6 and 2. Now I can safely cross out x minus 2, and I'm going to end up with 2x plus 3 over 3 times x minus 6, and x cannot be equal to 6 and 2. The next example is 2x squared minus 8x over x squared minus 3x minus 10 divided by 4x squared over x squared minus 9x plus 20. 2x squared minus 8x. 2x is common factor, so I'm going to write 2x times x minus 4. So that's the numerator of the first fraction divided by, now the denominator, again the leading coefficient is 1, so I can use sum and product to find two numbers. Product is negative 10, add up to negative 3 or negative 5 and 2. So I'm going to write as a minus 5 and x plus 2 divided by 4x squared. I'm just going to leave it as 4x squared. Now for x squared minus 9x plus 20, leading coefficient is 1, so find two numbers. Product is 20, add up to negative 9, and those two numbers are negative 4 and negative 5. So I'm going to write it at x minus 4, x minus 5. Now before I do anything, I'm going to write the restrictions. I can see that x cannot be equal to 5 because x minus 5 is 0. X cannot be negative 2 and x cannot be 4. So the restrictions are x cannot be equal to 5, negative 2, and 4. Now, since I'm dividing fractions, I can flip the second fraction and multiply. So I'm going to write as 2x, x minus 4 over x minus 5, x plus 2 times x minus 4, x minus 5 over 4x squared. And the restrictions are x cannot be 5, negative 2, and 4. But if I look at the denominator now, I have introduced another restriction, which is x cannot be equal to 0. So I'm going to add it to my list of restrictions. Now I'm going to go ahead and simplify. First of all, 2 cancels with 4, so you get 2 here. X cancels with square here. X minus 5 cancelled with x minus 5. And remember, I can simplify all these numerator and denominators because I've already included the restrictions. So I'm going to end up with x minus 4 times x minus 4 in the numerator, which is x minus 4 squared, divided by, there is a 2x here, so I get 2x times an x plus 2, and the restrictions are x cannot be equal to 5, negative 2, 4, and 0. The next question is 2y plus 3 over 3 minus 4y plus 4 plus y over 4y minus 3. I'm going to write the first fraction as 2y plus 3 over 3 minus 4y. But the second fraction, the denominator, I can take the negative out. So I get plus 4 plus y over negative times 3 minus 4y. Now this addition, plus and this minus sign, they multiply, they give you minus. So we get 2y plus 3 over 3 minus 4y minus 4 plus y over 3 minus 4y. Now, since the denominators are the same, I'm going to subtract the numerator. I get 2y plus 3 minus 4 minus y. I'm going to distribute negative inside the bracket here, and I get 3 minus 4y in the denominator. Now 2y minus y gives me y, 3 minus 4 gives me negative 1 over 3 minus 4y. And if you look at the denominator, y cannot be equal to 3 over 4. So that's our restriction. Again, how we found 3 over 4 is that make 3 minus 4y equal to 0 to find a 0. I'm going to move this one to the right. I get 4y is equal to 3 divided by 4. I get y is equal to 3 over 4, which is my restriction. In the next question, we have 4 over y squared plus 5y plus 6 minus 5 over y squared minus y minus 12. Again, we are going to simplify the denominators by factoring them. So the first denominator becomes, since the leading coefficient is 1, I have to find two numbers that the product is 6 add up to 5, and those are 3 and 2. So I can write this one as y plus 3 and y plus 2 minus, again, 2. The leading coefficient is 1, so find two numbers. The product is negative 12, add up to negative 1. Those are negative 4 and 3. So I get y minus 4, y plus 3. Now I'm going to find the common denominator. To do that, I will look at the denominators. Both of them, they have y plus 3. So what I do is that I multiply the numerator and denominator of the first fraction by y minus 4. So I multiply this guy by 1 y minus 4. And the second fractions, I'm going to multiply numerator and denominator by y plus 2. Now, if you look at the denominators, the restrictions they become so far is y cannot be equal to negative 3, negative 2, and 4. Now, if we take the common denominator of all of them, we get y plus 3, y plus 2, y minus 4. Now, the numerator here, I distribute 4 inside, I get 4y minus 16. And I distribute 5 inside this bracket, I get plus 5y plus 10, but there is a negative here, so it's going to be negative 5y, negative 10, with the same restriction, meaning y cannot be equal to negative 3, negative 2, and 4. Now 4y minus 5y gives me minus y. Negative 16 by negative 10 gives me negative 26 over y plus 3, y plus 2, y minus 4, and y cannot be equal to negative 3, negative 2, and 4. The next question is, we have been given the graph of the function y equal f of x. We are supposed to sketch and label the following. K of x is equal to f of x minus 3, m of x is f of x minus 3, and p of x is f of x plus 2 minus 1. Let's do the first one, which is f of x minus 3. If we look at this one, this means that every point on the graph, the y value is going to be subtracted 3 units, meaning that the graph is going to be shifted downward 3 units. So for this one, For the first one, I'm going to pick points, major points, and I'm going to subtract 3 from the y value. So let's start with this point here. I'm going to go 3 units down, so I'm going to get 1, 2, 3 here. This is corresponding point. For this point here, I'm going to go 3 units down, so 1, 2, 3, I'm going to end up here. For this point here, I'm going to go 1, 2, 3 down, so I'm going to end up here. For this point here, I'm going to go 3 units down, 1, 2, 3, and I'm going to end up here. For this point here, I'm going to go 3 units down, 1, 2, 3, and I'm going to end up here. And what I'm going to do is that I'm just going to connect the points together. So I'm going to end up something like this. Then I'm going to go here, and then I'm going to end up here. So this is going to be my part A. So I'm just going to write k of x. So this is k of x. Now for the second one, m of x is equal to f of x minus 3. If you remember the general equation of transformation of a function, it already is x minus h. So this means that h in this case for this function is positive 3. So this means that every point the x coordinate is going to be shifted right 3 units. So again, I do the same thing. I start with this point at the bottom, so I go 3 units right. 1, 2, and 3. 3 units right. So I'm going to end up somewhere around here. Then I'm going to pick the top point, so I'm going to go 3 units right, so it's going to be somewhere around here. Then I'm going to pick, let's say, this point here, and I'm going to go 1, 2, 3, so I'm going to end up here. Now I'm going to pick this point here, and I'm going to go 3 units right, which I'm going to end up here, the same place. And then I pick the last point here, and I'm going to go 3 points right, so I'm going to end up here. And then I'm going to connect the points together. So I'm going to get something like the following. So this represents m of x. The last one is p of x is equal to f of x plus 2 minus 1. You can see that it's plus 2, so h is negative 2, and it's negative 1, so k is negative 1. This means go 2 units to the right and 1 unit down. So again, I'm going to start with major points. Starting with this one, I go 2 units left, so I'm going to end up here, and then 1 unit down, so I'm going to end up here. I'm going to show them with a cross. For this point on the top, I go 2 units left and 1 unit down, so I'm going to end up somewhere around here. For this point here, I'm going to go 2 units left and then 1 unit down, so I'm going to end up here. And for this one, I'm going to go 2 units left and then 1 unit down, so I'm going to end up here. And then now I'm going to connect the points together. So I'm going to get something like this dashed line. So this is going to be my P of x. In the next question, we are given a function g of x is 1 over x plus 3 minus 8. What is the base function? The first question, the base function obviously is h of x 1 over x. If the general form of a transfer function is given by this function, specify parameters a, b, h, k. We can see that a is equal to 1, b is equal to 1, because the coefficient of x in the denominator does not have is equal to 1 over. There is no coefficient here. H, because h is automatically x minus h, and this one is x plus 3, so h is negative 3, and k is negative 8. Now in words describe the transformation required to apply to base function a to get the graph of g of x. So for step 1, we say that we start with graph of 1 over x, which is the base function. The second one, since h is negative 3, so we say move or translate left along x-axis by 3 units. And the last step, 3, move or translate down along y-axis by 8 units. The next question is, what is the equation of vertical asymptote? Remember, vertical asymptote is any x value that makes the denominator 0 and the function undefined. The only thing that makes the denominator 0 is when we solve x plus 3 equal to 0. So from here, if I move 3 to the right, I get x is equal to negative 3. So my vertical asymptote is the line x equal to negative 3. What is the equation of the horizontal asymptote? As I mentioned before, for horizontal asymptote, we have to find the highest exponent of the variable in the numerator and the highest exponent of the variable in the denominator, and then we simplify. To do that one, we have to simplify the fraction. Now, the equation is y is equal to, or g of x is equal to 1 over x plus 3 minus 8. This one, I can multiply this by x plus 3, divide by x plus 3, so I can find the common denominator, which is x plus 3. From the first one I get 1. The second one, if I distribute negative 8 inside, I get negative 8x, negative 24, which is going to give me negative 8x minus 23 over x plus 3. Now the highest exponent of numerator is negative 8x, and the highest exponent in the denominator is x. If I simplify this one, I get negative 8. So this means y equal negative 8 is going to be my horizontal asymptote. Another method of doing that is look at g of x when x goes to infinity. 1 over x plus 3 goes to 0 because 1 over infinity plus 3 is 1 over infinity, which is 0. So this fraction is not going to contribute anything when x goes to a very large number. So the only thing which is contributing to this g of x is going to be minus 8 now. That's why, y equal to minus 8 is going to be our horizontal asymptote. Now to graph g of x, I know the vertical asymptote we found before is x minus 3, which is going to be a vertical line like this one. And our horizontal asymptote we found is y equal to negative 8, which is going to be this line. Now we have to find x-intercept and y-intercept. Remember that the function is g of x is 1 over x plus 3 minus 8. X-intercept is when g of x or y is equal to 0, and it can easily be seen that if g of x is equal to 0, 1 over x plus 3 minus 8 is 0, so 1 over x plus 3 becomes 8. So 8x, if I cross multiply, I get 8x plus 24 is equal to 1. So 8x is equal to 1 minus 24, which is minus 23. So x is equal to negative 23 over 8, and negative 23 over 8 is approximately negative 2.9. So my x-intercept is negative 2.9, which is going to be somewhere around here. And for y-intercept, I'm going to set x equal to 0, so I'm going to get 1 over 3 minus 8, which is 1 over 3 minus 24 over 3, which is going to give me minus 23 over 3, which is going to be negative 7.7. So the point is going to be somewhere close to the asymptote here, and graph looks something like this one. This is going to be my graph, but since the graph of rational function is going to have 2 branches, the next branch is going to be something like this. So this is going to be the graph of g of x. The second part of the question, part G, says if the base function is now g of x, this means that this graph that we just plotted is going to be our base function. What are the values of parameters a, b, h, k if g of x is transformed to h of x is equal to 1 over x minus 3 plus 2? Now, before we do anything, we are going to simplify the fraction by finding the common denominator. So we say that h of x is the same as 1 over x minus 3 plus 2 times x minus 3 over x minus 3 to have the same common denominator. This one gives us x minus 3, 1, and then distribute 2 inside the bracket. We get plus 2x minus 6, which is 2x minus 5 over x minus 3. Now the function h of x is going to have x minus 3 equal to 0. Then we are going to get x equal to 3 is going to be our vertical asymptote. So vertical asymptote is going to be x equal to 3. Now if we let x go to infinity, the highest exponent of x in the numerator is 2x, and the one in the denominator is x. If we simplify it, we get 2. So we say that the horizontal asymptote is y is equal to 2. Now if I plot these two asymptotes, vertical asymptote is going to be x equal to 3, and the horizontal is y equal to 2. You can see that the origin has moved to this point. From this point, it has gone up to this point. This means that the previous origin has moved up 8 and 10, 10 units up, and then 6 units to the right. Since it has gone up 10 units along the y-axis, I can say that k is equal to 10. Since it has gone right 6 units, I can say h is equal to 6. Since there is no stretch or compression along the x or y axis, I can say that a is 1 and b is equal to 1. So these are the values of my parameters.